We are now moving to solving systems of equations. So we learned in KC2 how to solve equations. Now we are going to be able to solve for both equations. So we're not just solving for one, we're solving for both. So we're solving for the systems of equations. And there's two ways to do this. There's substitution and elimination. So what we're going to be learning today is about substitution. So let me again explain what substitution means, okay? Substitution just means plug in what you know of that variable, okay? So I find substitution to be one of the easiest. Um, Give me a second. Okay, sorry. So again, substitution is one of the easiest, I personally think, and all you have to do is plug in for that value. So I don't know if you guys remember when we were solving equations, and I even told you that you could check your answer. So for example, if I had the equation, let's just say 2x equals 12, right? In order for me to solve for x, I will have to divide for this, right? Because it's 2 times x. I want x by itself, so I will have to divide by 2. Whatever you do to one side, you do it to the other side. So now I have x equals 6. So now I know that x equals 6, right? I can use substitution to plug it into my original equation, which was 2x plus 12. X is 6, and I'm using x. So instead of plugging x, you're going to be plugging the number 6 because you already know that that is what x represents. So it's 2, and I already know it's 2 times x, and so it's going to be 2 times 6 equals 12. Okay, you're plugging in the value of x by substitution. Okay, we also did this method in transforming graphs. Remember that f of x equals, for example, 2x plus 4. And when you were doing the transformation, they were telling you, okay, do the f of x plus 3. And I told you, they already gave you f of x. F of x is right here. So all you're going to do is substitute it for it. So instead of plugging in or writing f of x, you already know that f of x is 2x plus 4. And that you were going to be adding 3 to this. That is substitution. So the same thing here, okay? For substitution, you definitely want at least one of the equations to be in slope-intercept form. So you want at least one of the equations to be in y-intercept form, which is also the slope-intercept form. All right, so again, y equals mx plus b. You want an equation where they already give you the answer for y. Y is going to be whatever they have on the other side. So that way, it's easy for you to plug in and substitute y because you already know what they're giving you. All right, so you definitely want at least of the equations to be in slope-intercept form. So let's go ahead and try number 5 for this one. You have the first equation. As you can see, this first equation is in standard form. This one's in standard form. How do I know it's a standard form? Because I have the x and the y, the input and the output, on the same side. And again, what do I mean by the same side? Don't forget that 2x minus 3y equals -1. The equal sign tells me I have the left and the right. And so when I'm telling you that the input and the output are in the same side, this is what I mean. They are both in the left side. So this is called a standard form. All right. Then the next equation, if you notice the next equation, I do have it in slope-intercept form. That means that y equals x minus 1. Y, wherever you see the y, you're going to plug in x minus 1 because that's what the y equals. So we are going to going to use the standard form, so 2x minus 3y equals negative 1, to plug in the second equation. The second equation again is right here. So wherever you see the y, you're going to plug in x minus 1. 2x minus 3y. I see y right here, so instead of writing y, I'm going to plug in this. And every time you plug in, don't forget that you're multiplying, okay? Because you have 3 times y, so that means that you're going to be multiplying with the answer of y. So let me write this again. So 2x minus 3, and again, I'm plugging for y. Again, I'm putting in parentheses because parentheses means multiplication. So x minus 1 equals negative 1. Okay, once again, I just plug in for y. They gave you the answer for y in the second one, and I'm using the first one, which is in standard form, to solve for this. And all you're going to do once you plug it in is solve. The first thing we have to do here is get rid of this parentheses by distribution. So now it means I have negative 3x, because negative 3 times x is negative 3x. Negative 3 times a negative 1 gives me a positive 3. And again, we need to be really careful with our negatives, okay? I didn't do anything to the 2x, so I just bring it down. I didn't do anything to the negative 1, so I bring it down. Just like we learned in solving equations, we are going to combine like terms first, because I have 3 terms on the left, 1 on the right. I have so many terms on the left. Let's get rid of them. How do you do that? By combining like terms. The terms that I'm going to be combining for this is going to be 2x minus 3x. Why? Because they both have an x. And remember, when we are combining like terms, we are just adding and subtracting those two numbers. We're not doing the opposite of anything, okay? We are working on the same side, so we're just going to be adding or subtracting them. We're not doing the opposite of anything. So 2x minus 3x, okay, is going to give me negative x, negative 1x. Do I have to put the 1 in front of the x? No, not really. So it stays like that. Once again, I bring everything else that I didn't use, which was a positive 3 minus 1. All right, once again, I can go ahead and solve for this. It's an equation, back to equations. All right, what am I going to do to get x by itself? Well, I need to move the 3 to the other side, because I need to get rid of that 3 since it's next to x, and I just want x by itself. To get rid of 3, you subtract 3 from both sides, so now I have negative x equals, this cancels out, negative 4. And once again, don't forget that I told you that your variables can never be negative. So if they are ever negative, don't forget we have an imaginary 1 here. So it's saying negative 1 times x, okay? Any number next to x means multiplication. So to get rid of this negative 1, we're going to divide by negative 1. Whatever you do to one side, you got to do it to the other side. Therefore, my answer is going to be x equals positive 4. Okay, so that's my answer. All right, so once you have the answer for x, don't forget that I keep telling you that our solutions are written as coordinate points. Have an x value and a y value. So far, I know I have the x value. X is 4, so I'm going to plug it in for here. My answer so far is 4, comma. I don't know the y yet. It's a question mark. But we can definitely figure it out. Why? Because if we go back, what we substitute was for the y. Y equals x minus 1. So all you have to do is, again, substitution. Plug in the value that you know for x. Again, y equals. And again, y, you can use any equation. You could use this one or this one to figure out how much is y. However, if you notice the slope-intercept form, you already have y by itself. All you have to do is plug in on the other side, because then you know y equals something. Same thing here. You see how x is by itself already? Okay, Why not work with the equation they already gave you y by itself? Again, the equation is x minus 1. How much is x? X is 4, and again, it's right here. I figure it out. So all I have to do is plug in for 4. So this is 4, and I'm subtracting 1. That means that y equals 3. So that's what my y equals, and so I'm going to plug it in for my question mark, which I already know is a 3. So then this is my final answer. This right here is my answer. This means I have one solution, and that solution is at 4, 3. Okay, so substitution again means plugging in for what you know for that variable. Okay, it's always going to be plugging in, substitute, replace it. Someone told me that word, replace what you know. Okay, that's what substitution means. Replace what you know for y, replace what you know for x, and you'll figure out your answer. Okay, so I'm gonna go ahead and try number 6. One more problem with you guys. Let me just write those equations a little bit more bigger so we can see them very clear. All right, for this one, okay, we have the first equation. It doesn't look like the y, the slope-intercept form, which is the y equals mx plus b. It does not look like it, right? Because I have y on the right, and I have, again, left and right. Okay, I have the x by itself on the left, and I have negative 2y on the right. However, they didn't give you the y for this one. However, they did give you how much is y. Y is negative 2y. Okay, on the second equation, they give it to you in standard form. X and y are together on the left, and your constant is on the right. So therefore, I don't know what x or y equals to for the second one, okay? Both of them are together, so I don't know. What I do know based on the first equation that x equals negative 2y. So that's what we're going to use, okay? You are looking for the variable that it's by itself already on one of the sides, either left or right. As you can see, x is by itself on the left, so that's what we're going to use to substitute. We are going to be replacing x, not y for this one. We're going to be replacing x. What are we going to replace it with? The negative 2y. All right, that means I'm going to use this equation. X minus y equals 9. I know x, so I'm going to replace it. Replace it. How much is the x? Negative 2y. And what did we have? Minus y equals 9. Go ahead and solve for it. As you can see on the left side, we have negative 2y minus y. We can go ahead and subtract it because they're like terms. Okay, so negative 2y minus y gives me negative 3y equals 9. To solve for y, I need to divide by negative 3. Whatever you do to one side, you gotta do it to the other side. So y equals negative 3. Okay, so I figured out the answer for y. So let me change my color now. Now I know that y equals negative 3. And don't forget that I told you your answer has to be in a coordinate point, x and y. I only know the answer for y right now, which is negative 3. I need to figure out the x. And once again, I'm going to use the equation where x is by itself already, which once again is the first equation that we use, this one. Okay, so x equals negative 2y. X is already by itself. All I have to do is replace the y because I already know how much is y. So x equals negative 2 times, because that's what negative 2y means, negative 2 times y. And how much is y? Negative 3. And again, How do I know it's negative 3? Because I figured it out. It's right here. I am just replacing what I know for y. So all I have to do now is multiply. Negative 2 times negative 3 is going to be positive 6. So now I know my answer is 6, comma, negative 3. This right here is my answer. Once again, this means it's one solution. So this one is a little bit different because y was not by itself. It was actually the letter x. However, we were able to replace it. We were able to substitute it. So that's how we do these. You can go ahead and try the next one and then try again your practice packet. If you have any questions, please let me know. These do get a little bit hard, so I understand if we're not getting them. But again, think of replacement, okay? Substitution means replace.